Hello, GM everyone. If you can hear me, please send an emoji. If you can hear me, please send an emoji. Adewale, are you there? Hello, Adewale, are you there? If you can hear me, please send an emoji. Or send chats. Send a message in the chat box. Okay, that's awesome. So, King, we're waiting for you to join us, please. Hello. Yeah, welcome, King. You can start sharing your screen now. Hello, King, can you hear me? Hello, King, welcome. Can you hear me?
Yes, I can hear you. Can you hear me?
Yeah, I can hear you too. Thank you very much. Okay, let's continue. So let's you can start sharing your screen now. Check this.
Morning, everyone. Yeah, welcome to today's class. Today is going to be our last class on Ethers.js. And what we'll be looking at today is Ethers.js function calls and transaction. The objective for today's class are function calls and transaction and how to call this function with Ethers.js and also perform transactions. Primarily, we'll be focusing on contracts, our smart contracts. How can we read our smart contracts? In our previous class, which was on Monday, we looked at signers, we looked at providers, how to link your MetaMask to Ethers.js using window.ethereum. So today we'll be looking at how to read contracts, how to make the function calls out of this contract, and how to perform our transactions. Now, in terms of function calls and transaction, what is function calls? So a function call involves invoking a function within a smart contract to read data from the blockchain. Now, at this point, we all know how function works in our smart contract. Even we know how to read, how to make calls to, like, how to invoke a function, making use of the parenthesis. That is, you like write the name of the function and then append the parenthesis together with parameters. If there's no parameter, you leave it empty. So when we talk about invoking function, that's you calling a function. That's a function call. When a function call is made, it retrieves data from the contract state, such as querying a token balance or fetching some stored information. At this point, we know and understand that there's like pure function and then there's like view function types. Now, all of this, depending on the function type, they all retrieve data from the contract state. And making use of a function call, we can read data from the blockchain in Ethers.js. Now we also have transaction. In contrast to a function call, a transaction is used to modify the state of the blockchain. Transactions are essential for changing data, transferring tokens on Ether, and executing functions that alter the smart contract state. So a modification of the state of the blockchain. When we talk about state of the blockchain, I need us to understand that we're talking about the data stored on the blockchain, that is your variables. If you want to change the value stored to a variable, that's like you modifying the state of that variable. So in terms of modifying the state of the blockchain, transaction is used to do that. Now, if you want to change data, you want to add more data, if you want to transfer tokens, you want to transfer Ethers, if you want to execute function that alters the smart contract state, all of this can be done as a transaction. Yeah. So we'll be looking at how to make function calls with Ethers.js. We'll still do the practical section, but this is just like an overview of how you can do this. Now, the first step is you connect to the Arbitrum network. So use Ethers.js to connect to an Arbitrum node, either a local node or a public one, to interact with the blockchain. By now, we should know how to connect you should know how to make use of Ethers.js to connect to the Arbitrum network, I believe. Yeah, making use of providers and the signers. So we did that in the last class. So this point should be understood by us. Now, the next thing is you need the contract ABI, application binary interface. We spoke about it in the last class, where it's like an abstraction of your contract. So you need to get that first if you want to read state from your contract. If you want to make a function call from your contract, you need to get the API. And API is essentially a JSON representation of the contract, smart contract functions, and the input and output. So if you read the JSON of each API, like read the JSON file. When we talk about JSON, is it like a type of file? Same way we have your Solidity file where you use .sol. When we talk about JSON, we're talking about you make use of like your .json file. Now, for each of the function or variable, they're going to have their own object, like in a JSON. And from there, you can understand what is required. One, you can view the input of that particular function. So you're going to see it in an array, I believe. Yes, you're going to see it in an array. You would see the first argument, second argument. If there's no argument, you see an empty array. So taking a look at the input, you can actually know what parameters to pass into your function. And then there's another which you would see in your API, which is the output. This output is also written in an array. It kind of specifies what to expect as a result from that particular function call. So the same way in your smart contract, you have like your return, where in brackets you add what is expected, if it's going to be an integer, if it's going to be a string. Same way in your API file, it's going to be specified there using the output. And from there, you can now specifically can know how to work with the return value of the smart contract function. There are also other types. I think you would see the function type where you can know if it's a view function, if it's like a non-payable function and the rest. So during the practical session, we'll see how a contract API looks like, and we'll also take a look at how to interact with it. Now, once you get your contract interface, that is your contract API, the next thing you need to do is you need an Ethereum wallet to sign and send transaction. Ethers.js supports various types of wallets, including private-based wallets, MetaMask integration, hardware wallet, and the rest. The next, so you need to initialize your wallet. And then lastly, you can now construct a transaction object specifying details such as the toll address and the value, data, gas limit, and gas price. Now, once this transaction is initiated and once mined, it updates the blockchain state. Now, we did something similar where using signers, we performed a transaction in the last class, making use of the toll and value, where we specified the value in meters and also the address where we want to send it to. Yeah, we also specified the gas price. Yeah. Now, in terms of reading contracts, what you need is you need the address where the contract was deployed. I believe you know how to get that, the particular address, the smart contract address, and then we need the API of that contract and also your provider. Once you have all those three, you can now initialize the contract inside of your Ethers.js, and you can begin to read each function call and even variable name, such as you want. So thank you for listening. This is all for the theoretical part. We're moving on to the practical session. Yeah. All right. So Oracle.
GM everyone. GM once again. So today we'll be looking into how we can interact with smart contracts using Ethers.js. So what we'll be doing is that we use the environment we used last week for the last class, which is the GitHub code space. I'm trying to set it up now so that I can. Okay. I'm going to be sharing my screen now. So okay, so if you get check our GitHub, this is the code we're using today, and you can see that it's just few lines of code. The first thing we're doing is we'll be initializing our provider, which is the Web3 provider. Then we pass the Windows.Ethereum to it. Then the next thing is we also initialize a smart contract, a contract. Um, so there are three parameters we are going to be passing. The first one is the address of the contract, the ABI, and the provider or the signer, depending. So, but for this one, I'm using just provider. So once you get those three info, then you can now call any method you want to call as if you are, interacting with a normal JavaScript. So that's how it works basically. And so I'm going to be creating a new file. Let me try to zoom in my screen. Can you guys see my screen very well? Let me try to check. Can you see my screen? If you can see my screen, please send an emoji. You can see my screen, please send an emoji. Okay, yeah, thank you. So let's now create a new file. Let's name it practice.html. So what we do is we create our boilerplate, which is a very simple HTML file. So let's name it connecting to MetaMask via Ethers.js. So yeah, so this is basically, and next thing is we need to add our scripts. We have everything we need here. So this is the script we'll be adding to load the Ethers JS library. So let's put it on at the top of the page, which is inside the head tag, the same way we did last week. So the next thing is we are going to add the second script. But this time around, it's a module. You have to make sure that it's a type module and all this source is not really necessary. It's going to be inline. So now, next thing is for us to now start working with the JS library. As I've specified in this file, the first thing you have to do is to initialize your provider using this line of code. So you can just come here and say and paste it. Get a const, which is constant, const provider. Let me close this tab. Const provider is equal to new ethers dot providers dot web3 provider, then Windows dot Ethereum. So that's how to initialize your provider. So next thing is that you will notice that we are not connecting to any wallet in this code. We are just trying to interact with smart contracts. And that's because for you to reach data from the blockchain, you don't really need to be authenticated. You don't need to have a wallet. Anyone can read data from the blockchain. So, but for you to now send a transaction, for you to modify the state of the blockchain, you need to be authenticated. You need to use a wallet. So, since we are using a provider and we are not modifying, just want to read. We don't need a wallet. Basically, you can read. So now to read, what do you want to read? So let's come to our Remix and deploy a very simple contract. This is a contract that comes with Remix by default. It's called Remix by default. It's called storage contracts. So what does basically is that it stores a value and also like retrieve values. So that's what it does basically. So the next thing now is for us to deploy this contract on Arbitrum Sepolia. Try to. So yeah. So this is the injected provider already. The next thing is let's try to deploy it. Let's save it so that we can compile. Let's click on deploy. It's pending. Let's approve. And we are good to go. Sorry, that was an error. Okay, so the same way we used to do before, like when you click on retrieve, you can see it is 0. That means that nothing has been stored yet. Let's try to save something like 10. It's going to transact. Then we are going to approve this, and we try to reach data now. It's now 10. So that's how it works basically. So but what if you want to interact with this smart contract via our code? We don't want to come to Remix. What we need to do is we need to get the address of the smart contract. So if you come back to this page, you can see that we have this line of code, new Ethers.contracts, which is for us to initialize the contract. There are 3 parameters you need to pass: the address, the API, and the provider or signer. But for this time around, we are just using the provider and not passing the signer yet. So let's come back to our code and see what was our contract. I can call it storage contract or storage. Let's name it storage is equal to new ethers dot contracts. Then pass those 3 parameters. The first one is a string of the address. Second one is the API, and the third one is the provider. We have the provider already. The only thing left is the API. So how do you get the API? What's API and how does API look like? We've done this in previous classes. We've talked about application binary interface, and it's a way for you to, interact with your smart contract. It's like an external, is like an API for you to interact with your smart contract. So when you come to this tab in your Remix, which is the compiler tab, Solid compiler tab, scroll down, you can see there's a button towards the end of the page called ABI. Let me zoom in. ABI. This, copy it. So once you copy it, you copy the ABI and create a new file. Let's create a new file here. Let's just name it anything we want. You can say, can name it here. Let's say ABI.json. Because ABI is always in JSON format, so it makes sense to name it .json at the back. So now, so the next thing is if you look at the API, you see it's very like similar to all these JSON file and stuff. At first, you might not really need to understand what this thing is all about, but it's just trying to specify, okay, that these are the type of interface that is exposed. Is a function, is non-payable. The name of the function is a store. These are the input parameters and stuff like that. So that's what the API is all about. It describes the smart contracts. So now the next thing is paste your API into your code, which is just after the contract address. So we have everything we need already. So let's now try to compile this code let's try to like go live. Sorry, Let's try to go live. So once we go live, we can easily see our results and also interact with. Just come to training 15, then change URL to practice.html so that you can see what our new code. So yeah, the title already changed to connecting to Ethers via blah blah blah. So the next thing is for us to inspect. Let's check whether there's any error. So there's no error. So let's refresh again and see. So there's no error. That means our code is working perfectly. The next thing now is for us to now try to interact with the contract. You know, the other time I stored a value called 10. I stored 10 inside the smart contract. So let's see how we're going to retrieve our value back. So we can say await this storage. You can name it anything you like. If it is token contract, you can name it token. If it is storage, you can name it storage. It doesn't have to be storage, but that's just like a very simple name that we can remember. Then if you notice in our smart contracts, we have a function called retrieve, which is a view function, which allows us to read the value stored inside this number state variable. So let's come back to this our remix and paste the same thing. You see that it's dot retrieve. So let's save it. So the moment we save, there is nothing on screen, and that's because let me refresh that I can see. There's nothing in the console, there's nothing on screen. That's because we are just reading the value and not console.logging it. So let's log it so that we can see the value. Console.log, then the value. So this is it. You can see that there's a value now on the screen, and it's in hexadecimal format. So at the beginning of this class, of this training, I mentioned something that there are times you store value in hexadecimal format. So this hexadecimal format, 0x0a, means 10, is equivalent to 10 in decimal. So let me copy that value and paste it here. You can see that it's giving me 10. And the value stored in our um, storage in our contract is 10. So if I modify it and change it to something like maybe 100 or 1007, let me click on transact. Okay. So confirm. So the value should be 1007 by the time I refresh this page. Let me refresh. Now you see I get a new hexadecimal value, right? Let me copy it. This is a new hexadecimal value. Let me copy it and paste it inside the console. See, the value is 1007. That's how to basically retrieve data from the blockchain. And if you have any other method, you can call it. But let's go back to this our code and see that let's try to call store function or store method. So this method, what it does is that it stores particular value in the blockchain. So I'm going to change that retrieve with store, and you see what will happen. So when I change it to store, I can add like 100 because it's going to take a number. So let me save and let me try to refresh. Oh, you can see that there's an error already that a transaction requires a signer. You can see the error here. A transaction requires a signer. But what we have is just a provider in our contracts. But unlike a signer, a provider can only read while a signer can read and write. So for us to initialize our provider, we need to send a request using the ETH request account method. So for us to do that, let's go to the second file. So let's try to check it out. So this is what we need. ETH underscore request account. You can copy it and bring it to your code. So it's going to just be after the provider because you need to request for the account first before you can even, before you can start, before you can get the signer. So once you request for the account, the next thing is for you to get the signer. You can say await provider dot get signer. So this is going to help you to get the signer. I can store the signer inside a variable like const signer is equal to this. So once you do that, you can scroll down, then replace the provider with a signer. So let's save it. So the moment I save it, you see that there's something prompting up. There's something prompting up, and if you go back to your, let me close this MetaMask. So if you go back to your MetaMask, if you go back to your browser, try to refresh, you can see there is no error. The only thing you are getting now is like a prompt um, for you to confirm or like accept the transaction. But I don't want to do that yet. I want to go the other way. Let me try to disconnect first so I can see how the whole flow looks like. Let me try to disconnect. So yeah, you see I'm disconnected now from this site. Let me try to refresh. So the first thing I'm going to do is I'm going to first approve MetaMask to approve this site from accessing my MetaMask wallet. So once I approve it, then I will now sign the transaction, which is the second one, because let's go back to our code. You see the way the flow is. The first thing we did was to initialize the provider. The next thing is we try to request for accounts, which we approve. If you don't approve this, every other thing is going to fail. So after we approve, we get signer. That one is not going to prompt us it's not going to prompt us. The next thing is for us to now, add the signer to the contract, then now send the a transaction to store 100 inside the number state variable. So if you come back to your MetaMask, you can see at the top of this page, let me try to zoom if it's possible. Yeah, at the top, you can see that there's a method here like store. So meaning you are trying to store, you are trying to call the method store. If you are trying to call maybe transfer, trying to call any custom function or method, you are going to see the name here. But because you are trying to store, the name of the function is store. That's why we are seeing store there. So I'm left to accept or reject. The moment I accept, I confirmed. You see that I stored 100, right? So if I go back to my remix, if I try to say retrieve, see that the value is now 100, no longer 1007. So that's how to store something using Ethers.js. Then lastly, we can also store and retrieve at the same time. It doesn't really matter. But you will see that there's a difference, like in the way the normal traditional coding works. So it's because there will always be a delay for the transaction to be confirmed. So you cannot really store and retrieve in the same transaction. So let me try and do this. Let's try and store 718. Let's try to store it and let's try to refresh. The moment we refresh, we are getting a prompt to store a value, and the gas is $3.61 dollar. So let me confirm. So the moment I confirm, you can see I'm getting this transaction hash. We still come back there later. This transaction hash. You're also getting some other values, and yeah. But I'm concerned about this big number because we stored and we also retrieve at the same time. So if we try to put this number here now, let me copy this and paste it here. You see that the value is 100 because we're trying to store and retrieve at the same time. So there's going to be like a delay, like some seconds or milliseconds for the transaction to be confirmed. So that's why you are seeing this 100 instead of the new value we store. So the moment we refresh, let's try to refresh. And I don't want to save this. Let me just close this. Okay. Let me go and comment it in my code so that I don't want to like store any new value again. I've commented the store value, right? So let me now come back to my console. You can see I'm seeing a new value 0x2CE. So let me paste it here. And you can see it is 718. So this 718, and it is equivalent to the 718 we stored earlier, and that's how to store and retrieve data from the blockchain, and it is very, very simple and straightforward. Okay, so if you have any question now, you can start, requesting for mic, and I will, start taking your questions. If you have any question, please feel free to ask for the mic or drop it in the message box. Okay. So since there's no question, what we'll do now is that we will also talk about some of the information we can get whenever we send a transaction to the blockchain. So let me try to store this other value. Let me try to store 987. So now what I will do is that I will confirm this transaction. Let me confirm this one too. Okay. Okay. So you can see I have transaction hash, like has block hash, block number, chain ID, all those info. So gas limit, gas price, hash. So now this what I'm more concerned about is the transaction hash. So let me copy the transaction hash, which is hash. So let me try to copy it, and let me come here and say come. Okay. Let me go to Abiscan. Abiscan.sepolia.io. Yeah, so you can see that the transaction is on the blockchain already, and it has been confirmed by the sequencer like 47 seconds ago. That was like exactly the same time we perform the transaction. And you can also see that the transaction fee showing here is different from what MetaMask was showing us. MetaMask was showing like $3-4, but at the end of the day, we paid like 21 cents, which is far lower than what MetaMask predicted. So that's how it works at times. And you can also see more information about the um, about the transaction. You can see the input data. You can see that we called store, and these are the parameters we pass to it and other stuff like that. So you can also decode the input. And when you decode it, you see that this is the value we sent and stuff like that. And that's because this contract has been verified, because it's a very popular contract. So you can check the source code here. Let me check. It has similar contracts. You check similar contracts, you will see contract that with the same with the same. Let me try to decode it. So when you decode, you see the all the opcode and stuff like that. So that's how it works basically. And if you have any question, please feel free to drop. Feel free to drop it and on the WhatsApp platform. If you have any question, please you can drop it on the WhatsApp platform or in the message box. Please feel free to ask questions. Feel free to ask questions. Feel free to ask questions. If you have any question, please ask. Okay, someone is raising up. Let me check. Okay, Yusuf, yeah, let me make you allowed to talk. Okay. Yeah, Yusuf, you can now talk.
Oh, good morning, boss. Can you hear me?
Yeah, I can hear you. Good morning.
Oh yeah. Firstly, I'd like to appreciate the sacrifice and everything. So my question is basically from what I can see, anyone that wants to, like you said, that want to communicate with the blockchain, especially when you're doing transaction that requires gas or price, you have to connect to your wallet so that your transaction can be signed, right?
Yeah, yeah.
Okay. So now let's assume someone that has little knowledge about blockchain. I mean, maybe an elderly person that wants to use it, right? So is there a way we can help with that, like without in having to connect manually, right? Maybe you can do like a subscription, like normal subscription to like a platform that helps doing that instead of him doing that himself. Man, I don't know if you get my question.
Okay. What you mean is that you are looking to curate a kind of platform that doesn't require people connecting their wallet to your DApp, right? It's possible. There are a lot of ways you can achieve that. And during this program, we'll be looking at how to do that for those that will be doing the back end development, part. So they will learn something similar to that. But when you are working with front end and you need to build a DApp, basically you need a wallet that will help you, or some kind of abstraction that abstracts the wallet. So we're still going to answer that later on in the course. So that's a very good question, and thank you very much for asking that. So if you have any
Oh,
other
I think
question, mute.
thank you very much.
Yeah, thank you. Welcome. So if you have any other question, please ask. There's yeah, please, if you have any other question, feel free to ask. Okay, so no one is asking how to call a payable function because you need to pass funds, right? To do that, you just need to add another uh, argument like to the function call. Let me show you how to do that. Let's assume that this storage function is a payable function. You have to do something like comma, then say value. How much you want to send to it? And I say ethers dot you choose dot pass it out something. Then then put the amount of ether you want to send, and you are good to go. So you can put it as a string instead of this. So that's how it works basically. And let's try to deploy a contract that is payable. So that we can see how it works. Let's come back to our MetaMask. Let's make this one payable, public payable, right? Let's save it. Doesn't really matter. We're not doing any verification, but we need to send something along with the call.
Oh, sorry, boss, we can't see your screen again.
Oh, okay. Thanks for calling my attention to that. So you can see my screen right now, right?
We can.
Can you see my screen?
Yes, we can. We can.
Okay, what I did was I made this function payable. So I removed I added payable on the payable keyword. So the next thing is for me to now deploy this contract. So there's going to be a difference in the ABI because we added something new. So let's come here and say deploy. The moment I deploy, it's going to prompt me, and I'm going to pay certain amount as gas fee. Then I have the smart contract address already. I can see that this storage is now red instead of the normal orange. So I have gotten the address. Let me go back to my code and change the address to the new one. So I changed the address already. Then the ABI also, we need to change the ABI. So let me show you the difference between the new ABI now. Okay, let's go to our compiler tab. Let's scroll down. Let's get our ABI. So once you get your ABI, you can see that we have the former ABI up here, and we can have this one too. So let's scroll down. You see that there is this part called state mutability, non-payable. But when you scroll down a bit, you can see that this one state mutability is payable because you added a payable keyword to it. You can see this one is payable. The former one is non-payable. So that's why I said functions are non-payable by default until you add the payable keyword. So let's cut this and go back to our practice window. So what we'll be doing is we'll be adding the new API to this. Okay, let me try to remove everything. To talk some. So now let me save it. It's saved already. Okay, so we are done with this right now, but we still need one more thing. We need to, I don't want to store a value. Let's try to store a value like 98 or something we've not used before so that we can see that it's different. Let's do 345. This is another number. Then we are going to send 0.001 ether to this contract. This is a very small amount. Let's do 0. So I will not waste our test fund. So next thing is for me to go back to my, let me try to refresh this window. Okay, I'm not getting any prompts. Okay, yeah, we have a prompt. You can see that we have this store, right? Then we have the prompt and everything here, trying to tell us that okay, the total amount that will be expended is this, and you can see that the total amount plus gas fee is greater than the gas. That means we are also sending a certain amount with it. So let's confirm. The moment we confirm, it's successful, and I don't want to go back to my remix. What I want to do is I want to read the former value. So let me comment the store and let me try to retrieve. So the moment I retrieve something now, you see that I'm getting 0x159. Let me copy it and paste it here. You can see I have 345 stored in the contract. But we didn't just store value, we also like sent some ether along with our code. And how do we read the balance of that particular contract to show that it reflected the change, like the value stored in the contract increased? What we can do is that by saying ethers dot get balance, then let's put the address of the smart contract we want to like get the balance of. So let me copy it. I'm coming down here to paste it. Let's save. Okay. Oh, get balance is not a this thing. Sorry, it should be provider dot get balance. Sorry, not get balance. Provider dot get balance. So it's from the provider, not from Ethers.js, because you need to be connected to a provider to be able to reach balance. So you get what I'm trying to say. So okay, see that we are getting two values. We are getting one on line 50 and one on line 51. So what is now the difference between these two? One is the value we stored in the contract, and one is the balance, which is on the one on line 51 is the balance. This one is just the value. So let's copy this value here and paste it. Consider these the value stored in the contract. If you go to our favorite website, our ether parser, convert ether to convert ether to way. Let's put the way value. Consider this is the amount of ether we have in that contract, and that's how to read the balance of a particular contract. And this is the same with the value we sent along with the call. So that's how to call a payable function. You need to pass an extra parameter with it's going to be like a JSON value, an object. So it's going to be an object that you can use to pass on the value and the amount you want to send. So that's how it works basically. So if you have any question, please feel free to unmute, feel free to ask for mic. Since the last class, you have been using online IDE for Ethers.js. Does that mean we can't write our code with Ethers.js with our normal offline IDE? Yeah, that's a very good question. You can write your code offline. You can write it offline with VS Code. In fact, you can download Ethers.js libraries and use them in your React, in your other applications or stuff like that you are building. But just to make everything simple and straightforward, the process of setting up the IDE locally, it's going to be a bit cumbersome for people that are just coding for the first time. So if you have something like this online already set up for you, you don't need to worry about setting up everything. Everything comes out of the box, and you can easily understand what you are doing. You can easily focus on coding rather than trying to set up different tools. Do you get me? So that's why we are using the online IT. Do you get me? Okay, thank you. So if you have any question, please feel free to ask. If you can't ask for the mic, you can you can drop your message on WhatsApp or yeah. So
All right. Yeah, please can we look at how to listen to events using Ethers.js?
okay, yeah, that's beyond the scope of this class for now. So we're going to be doing that in the future classes, how to listen for events. But for now, it's beyond the scope of this class, and also you can also check that out on your own. It's beyond the scope of this class. So yeah, that's basically. But however, if you want to build anything that requires you to listen for events, we're going to be dropping resources on that, so you can check it out. Thank you very much, King, for that. Yeah, any other question? Any other question before we call it a day? Okay, since there's no other question, we'll be ending the call. Okay, thank you very much for coming, and hope to see you next week. We're having two classes next week, so you can join us fast as possible, and we are taking attendance. Thank you very much. Yeah. Yeah, please ensure you use your real name and full name next time. Yeah, bye bye.